that one, okay? Hint, hint, right? Because it's probably on the test. It's nothing that isn't really covered in others. It's just the context that it's covered. You might want to look at it. And it's something I know we've done. Okay, I picked it for the test because I'm like, oh, we've done this. I know we've done it. All right, and I do know, put the warning on it that we have, there are some things that landed in, like, especially the progress check piece, where there's some sign chart stuff loaded on. We're going to get better at sign charts when we go to Unit 5. I might not do as much of the sign charty stuff on the test. So when you see that, try it. We will solidify that understanding. It's going to make a lot more sense when we move to Unit 5. Okay. All right. So I've got my list that I'm going to start with. Let me get into the right place. I got too many tabs open. I don't know what happened. I had like one of those. I opened the computer this morning and like everything was, all the tabs were closed. Don't you love that? Because you were working on a bazillion things, right? And so everything was new, and I've already got like 5,000 tabs up again. So, oh well, it is what it is, right? You want to see the 5,000 tabs? You'll see flash in just a second here. 5,000 tabs. And this is bad as you guys. Maybe worse. I don't know. All right. I just had 10 added to the list. Okay, so we will do our best on getting through as many of these as we can in the next few minutes. Remember, you still, just because it's review doesn't mean we're not responding to me in the chat. Please respond to me in the chat. You are still getting participation. So this is me helping you get through these problems. It's not Mrs. Ballard just explaining them all, okay? And doing them all by herself, because that wouldn't be very much fun. All right, so I'm starting with 16 because that was the first one that was put in the chat. And this one looks like it's a little bit longer of one. The test will be between 10 and 15 questions long. We are going to see some that are like this longer type of question, which I know the state of California calls a performance task. Isn't that nice? For the SBAC, but we call it a free response question in calculus. So, so let's take a look at this one. We've got a velocity graph, and we know that because it tells us v of t right there on the graph. Okay. So for between 0 and 11 seconds, a particle moves along the x-axis. The velocity of the particle in meters per second can be modeled by the graph above, which consists of 4 line segments. Okay, so they tell us on the graph its velocity. They also say the velocity of the particle is up there. Okay. And I'm sorry, I'm going to have to scroll back and forth, okay? So it says that in the first question, we have to find the velocity at 3 and the acceleration at 3, okay? So all I'm going to do to find velocity, I have velocity. To find velocity, I'm going to go to my graph. I'm going to go to 3, and I'm going to read the y value off the graph. So I'm seeing a 4 there. So the velocity on this one should be 4. Okay. Can you tell me in the chat, what's the relationship between acceleration and velocity? What's the relationship between acceleration and velocity? Acceleration is the derivative of velocity. You need velocity to get acceleration. That is exactly right, right? So in order to get to velocity, in order to get to acceleration, I need the velocity. And Jocelyn was correct. I have to take the derivative of velocity to get to acceleration. What is the derivative? So what do we think of? What other word do we think of when we think derivative? Yes, we have learned something this year. We know that derivative means slope. So when I am looking at a graph and I know I need to get the derivative of velocity, right? And I have the velocity graph, I need to read the slope at 3. So what is the slope right here at 3? Can you guys tell me that? Oh, you guys are already ahead of me. Awesome, the slope is 0. Okay. So I'm guessing it's not this part of the problem that we needed help with. We got this part, right? So the slope is 0 because I've got a horizontal line here. Okay, so horizontal lines, the slope is 0. All right. Okay, so let's read the next part of the question. So that part, easy peasy, right? Okay, so it says, at what time does the particle change direction? Give a reason for your answer. Okay, so we're looking for a change of direction when I have a change in sign. Okay, so when velocity changes sign. Okay, so that means that it's going to move from a positive to a negative or a negative to a positive, meaning it's going to go from plus to minus or minus to plus, meaning I'm going to go from above the axis to below the axis or below the axis to above. So is there a place on the graph where that is happening? So what value am I going from above the axis to below the axis or below the axis to above the axis? And remember, we're only looking at, in this case, t values, but x values. Okay, nice job at 6. Perfect. So it changes direction at t equals 6. Now, you had to get the right answer typed in there. I'm not sure exactly how I'm going to have you do this on the test yet. You might have to type out the whole sentence, so it might not be bad to have your sentence frames here handy that I've done in the review. So I don't know exactly what I'm going to do with this quite yet, but we will see tomorrow. So the particle t of 6 changes directions because velocity changes sign at this value. Okay. All right. When we see the word average acceleration of the particle from t equals 2 to t equals 7 and indicate units of measure. This, whenever you see that word average with something that's a derivative word like acceleration or velocity, that means that we are going to be using the slope formula. Okay, like algebra 1 slope formula. That's what I need to do here. Okay. And there's a lot in this question, right? It's got like 6 parts, right? So there's a lot here. It covers a big chunk of this unit, right, in one question. So I can ask one question in 6 parts, and don't worry, I won't ask like 10 questions with 6 parts each. That's not nice, okay? You will have a little bit more time, so I'm extending the time on the test and putting more questions on because I want you to start building up the capacity to be able to do an AP test. Okay, so we're going to start that kind of this semester. And since we've got the block schedule, it's a little bit easier to do that. Okay, all right. So average, so I'm going to use the slope formula. So let's think about the slope formula. Slope formula is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I always go back to my roots, right? Go back to algebra. So in the context of this problem, I know my x values are these guys, right? So I'm going to do the bigger one first, 7 minus 2. And then I know the function I have is velocity. So I'm going to find the velocity at 7 minus the velocity at 2. Because that's what I have, right? And in order to get from acceleration to velocity, I got to do derivative or slope. So I'm going to go to my graph and I'm going to read that value for velocity off the graph. So I'm looking for v of 7. So 7's velocity looks like it's at -2. And then we're subtracting, and then the velocity at 2. So I'm going to go to 2, and I'm going to read the y value off the graph, and that is 4. So it's looking like my average acceleration is -6/5. Give you a minute. All right, let's look at t equals 9. So we're supposed to be figuring out if the particle is speeding up or slowing down, okay? So just in general, okay, how do we know the particle is speeding? Oh, it's saying it's wrong on Otis? Okay, so let me put a star. Let me see. -6. Oh, you know why? Because I didn't indicate units of measure, did I? Okay, so what would our units of measure be? What do you guys think our units of measure are on this one? We had to do acceleration. So what are we going to do for acceleration on this one? Okay, so meters per second would be velocity. How would I fix that to acceleration? There we go, meters per second squared. So, and I totally missed that. So if it says indicate units of measure, and you'll notice on one of the questions, I separated the answer from the units of measure, so that way it kind of grades it separately. And I might do that on the test too, so watch for that to happen. So we're gonna, and I don't know how I typed that in. I don't remember off the top of my head. So try meters per second maybe. Try that. See if that goes in. Know that I'm going to take all the answers that you type in on Otis. It just might take a little bit of finagling with this piece. I don't know if I did this. I might have even done that. I don't know which way I typed it in off the top of my head. So try a couple of those and one of them should work. Okay. And Casey, I'm glad you understand the mistake. Okay. So just know that anytime it's acceleration, it's always going to have the squared on it. Okay. All right, let's keep going. So speeding up and slowing down. Okay, so how do we know? I don't care about the question yet. How do we know something is speeding up? What do we know about acceleration and velocity if a particle is speeding up? All right, so they have the same signs if it's speeding up. So this is acceleration and velocity, same sign. Meaning if it's slowing down, acceleration and velocity have different signs. So if I am doing this by looking at my graph, okay, I need to figure out what my velocity and what my acceleration are at 9. Okay, so let's add, because since they gave us a specific value, let's do that. I would say specific value I'm probably going to put on the test. The interval I'm probably not going to put on this one. That will go on the Unit 5 test, even though I know some of the stuff on the unit on the progress check is the interval. So don't stress about the interval stuff yet. All right. So I am looking at velocity specifically at 9. I'm going to erase a little bit on here because I've scribbled a whole bunch. Okay, so velocity at 9 means I just get to read the y value. Looks like it's a -1. Okay, so equals -1, which is less than 0. It's negative, right? Now I'm going to try to find the acceleration at 9. So what am I going to read off the graph to find the acceleration at 9? What do I have to read? All right, if nothing else, we've got that one down. We know we've got to read the slope off the graph. All right, so it looks like we're up 1 over 2. So it looks like a slope of 1/2. So acceleration equals 1/2, which is bigger than 0. So that means it's positive. So are we speeding up or slowing down right now? Velocity is negative, acceleration is positive. What do we think? Speeding up or slowing down? All right, so we are definitely slowing down. So slowing down, okay, because, okay, so this is the way that I typed it in. I typed it in with the inequalities to be consistent with what we did in the notes. You could also say, depends on if I give you the sentence frame or not. You could say because velocity and acceleration have different signs. That's a perfectly good explanation. So if I just have you type in your own sentence, you could write that. Here, you would probably say, and probably velocity is listed first. Velocity of 9 is less than 0, and acceleration at 9 is greater than 0 is probably what I typed in there. Okay. All right, so check that out. We've done all of the, we've done speeding up, slowing down, changing direction. We've done acceleration. We've done velocity. Check this out. Now we're going to do a limit. Isn't that exciting? All in one problem, we've covered this stuff. This is what the AP test is like. It's like an insane amount of stuff jammed into one free response problem. But I want you to see that now so we don't freak out about it when we see this on the AP test. Okay? All right, so I'm going to have to move my work a little bit to the side because I wrote way too big. So the first thing I'm going to do is I'm going to plug in my 5, right? And I have to prove that both the numerator and the denominator is 0 if L'Hopital's rule applies. So and remember to write that out because I'm going to be looking at how you write this out. Okay, purposely not a multiple choice question because I want to see that you're doing this right and train you now to do it right so that when it comes time for the AP test, you have this down, and when we review, it's a breeze. Okay. Remember, you don't plug in there. I did one boo-boo on one of the examples in the homework or on the notes, which was my fault. But I write that out, and then I write out v of 5 minus 2. So I got to go back to my graph, and I got to grab v of 5. So v of 5 looks like it is, lo and behold, it's a 2, right? So surprise, surprise. Ooh, I am getting 0 in the numerator. Okay, so now let's calculate the denominator. Let me guess what I'm going to get. Limit as x approaches 5 of t squared minus 4t minus 5. And I know that seems like a waste to write down, but again, that's the proper notation to write. Okay. All right, so I'm going to plug in the 5. So I've got, I'm going to do it in my head, 25 minus 20 minus 5, right? So I did a little bit of work in my head. So 5 squared is 25, negative 4 times 5 is negative 20. And lo and behold, I also get 0. So technically, what's the name of the form that we have when we have 0 over 0? What's the name of that form? Trying to trick you on what the answer is supposed to be, because I bet you all were already typing something else. It's a big, long word. It's a fancy word. What do we call that form? Ah, Jocelyn gets, oh, Jocelyn and Bianca, nice. And Casey and Stephanie and Marissa and Sach. All right. Now, if I have indeterminate form, what rule do I need to apply? So now what am I going to do with this thing? Oh, yeah, we need good old L'Hopital's rule, right? Okay, so we're L'Hopital's rule says we're taking the derivative of the top, derivative of the bottom, and there isn't anything crazy going on, okay? If you do look at that progress check one, which is what you're supposed to do during async time, they do some crazy stuff there. There's some product rules in their L'Hopital's rule. Okay, there's one with a product and a chain. That's fair game for the test. You still should know all those rules. Okay, so I might pull one of those out. It might be I do one nice one and one kind of one that has something extra in it. So make sure you're looking for that, because again, I want to get your brain stretched and prepared for me. Okay, all right. So the limit, so I'm going to do L'Hopital, and I usually just write that notation. You don't have to have it, but that's my telling my brain, hey, I'm doing L'Hopital's rule. All right, so I know that derivative of v is v prime. What's the derivative of negative 2? Can you tell me that in the chat? What's the derivative of negative 2? Awesome, we haven't forgotten our simplest derivative ever. Good. And then it's 2t minus 4 in the denominator. All right, so let's plug in the 5 again. And again, at this step, if you see that your denominator is going to go to 0, I would do the limits separately like this. You can still do them separately. If it's not going to 0, I kind of have the option to just plug in right here. So I could do 2 times 5 minus 4, which it looks like my denominator is 6. And then I'm going to do v prime of 5. All right, so again, if I'm looking for v prime of 5, what am I reading off the graph? Okay, we are reading the slope. That's what you're telling me, so that's what I'm going to go do. So v prime of 5, I'm reading this slope right here. So I'm going down 2 over 1. So it looks like a negative 2. All right, negative 2. So it looks like it's probably going to read a negative 1/3 is the answer. I know we're taking forever on this one problem, and I'm sorry. Okay. I will do the best I can. I'll even use my lunchtime if I need to video a few extras if we need to, so we get through. You guys at least have video on everything. Okay. This has a lot of good stuff in it, right? Okay, so this was a good one to pick for number 1 because we have a ton of stuff in here. Okay, so the last part of this problem. It is known that x of 9 equals 2. That's something that we call an initial condition. Okay. Is the particle moving towards or away from the origin at time t equals 9? Explain your reasoning. Okay, and I know this was something that you probably did in video and I didn't explain it initially. Okay, if you went to the Saturday thing, he explained it a little bit. but we need to make sure we understand this. So we know we are starting at, so I'm going to draw a little bit of a number line. So I know I'm starting at x of 9 equals 2. Okay. So that is my t value. I need to know what's going on. I'm thinking through it. Hang on. So I need to know what's going on with the velocity at 9. Okay, so that's what I'm going to do. I'm going to move my velocity calculation at 9. So velocity at 9, I'm going to go back to my graph because that's the one I haven't calculated yet. Velocity at 9, I guess I do have it somewhere, is -1. Okay. So, and there is a chart in your notes that has a lot of this on it. That would be something I'd make sure I either have that rewritten on a page. So I have a 1-pager for my test, or I have that chart easily there available so I can look at it. Okay. So my velocity is negative. That means I am moving to the left. And because my t value is at 9, my origin is at 0. Are we moving towards the origin or away from the origin? What do you guys think? Yeah, and do you see how just drawing that much of a little picture, right? It's a number line. I know that the x value on my number line is 9. I know that my my origin is at x equals 0 or t equals 0. And then I drew that picture. It was enough to tell me that I have to go back towards the origin. Okay, so we're going to say that we're moving towards the origin. And I don't know if I probably typed in toward, not towards, at the time t equals 9, because x of 9 equals 2 is it's to the right side of the origin at time t equals 9, and the particle is moving to the left. My guess is it was filling in the blanks, right? Because we might not have been a little bit iffy on the blanks. All right, so that took care of the first one you guys asked me for, which was 16. That was a doozy. Okay, but it was a good one. We covered a ton of concepts in there. Okay. All right, so we've got about 20 minutes left. Okay, so let's pop up to 2 and see if we can get through a few more of these. Okay. All right, so item 2 is this guy right here. So item 2 is going to be another one that we've got a bunch of parts to, isn't it? Okay, so let's see what we can do with item number 2. Okay, so again, they give us a nice graph. Okay, and the upside of the graphs is we don't have a lot of work to do. We have a lot of analyzing to do. Okay, so graph below gives velocity. So we're in velocity. Moving along the x-axis, it can be defined by a continuous linear piecewise function. Note that v prime of t equals 0 on 3 to 4. So basically they're telling us, oh, that so this isn't really representing velocity. It's what's the derivative of velocity? What's it representing? The derivative of velocity. What's the derivative of velocity mean? The acceleration. So I could rewrite that as the acceleration, which equals the derivative of velocity, equals 0 on 3 to 4, which we could have probably gotten out of the graph because it's just talking about the slope on the graph, right? Okay, so let's look at what they're wanting us to do. Over which time interval is the particle moved to the left? Justify your answer, okay? So we want to look at when the velocity, so if we're moving to the left, okay, that means that the velocity has to be negative. Okay, so that means my graph has to be below the x-axis. Okay, so I would say the particle moves to the left, and then it says list the smaller interval first, and I would want to say that I probably use inequality notation. Okay, so what is the first interval where the velocity is below the x-axis? You guys tell me that? Where am I below the x-axis? So I'm below here, and I am below here. So I would use those X. I think we're in X's. Are we in X's? No, we're in T. So we would have to use T. Okay, so I know I said X, so that was my mistake. It should be in T's in our inequality there. So maybe that could be part of the problem too. So we're going to go 0 to 2. So 0 less than T less than 2. And then my other one was 6 to 9. So 6 less than T less than 9, because the velocity is less than 0. So velocity of T is less than 0. I would say you could say the velocity is negative as well. It just might not have fit in the amount of space that there was to type. I don't know if that was an unlimited space one. Okay. All right. Now these intervals with the graph is fair game. There's some that you had to do some derivative and sign chart. That we're not going to do the sign chart on this. All right, so over what time intervals is it speeding up? Okay, so speeding up, let's see if we've remembered something from earlier on. Speeding up means what about acceleration and velocity? All right, so we know that acceleration and velocity have to have the same signs, okay? So that means if I'm looking at the graph, I want it to be either above with positive slope or below with negative slope. That would make the signs the same. I don't know why I wrote a negative, right? Negative slope. Okay, so let me undo my highlights there, okay? So I'm looking above the axis with positive slope. This is my first one. Above with positive. There's no other above with positive. So I know one of my intervals is 2 to 3. 2 less than T less than 3. Okay. And I would say speeding up, on the interval, I'm going to go here is where that should have gone, right? All right. And then let's see if there's any negative in below. Negative and below. Oh, there is a negative in below. I wonder why I didn't include that one. Oh, wait, is there another negative, another thing? Yes, there's another thing. So there's another set of intervals there. Okay. So my negative and below is here. And it's because the reasoning was different. That's why I probably had them separate. So that's from 6 to 8. So 6 less than T less than 8. Okay, so on this one, it would be because the velocity and the acceleration are positive. Here it'd be because they're both negative. So we have to write that in math, right? So because the velocity of T is greater than 0 and the acceleration of T is greater than 0. Here we go the opposite. Velocity of T less than 0, acceleration of T less than 0. Okay, so again, it's a lot of it is just learning the notation. And I'm going to guess that's where we were getting tripped up on. Okay, so, and again, I did 2 of these because there were probably 2 different reasons. Okay, so over which time intervals is the speed decreasing? So this means, so I did an increasing, now we got to talk about decreasing. So when we're increasing, okay, that means that so this is the same as saying slowing down. So that means if we are slowing down or our speed is decreasing, what do we know about the signs of acceleration and velocity? Tell me in the chat, what do we know about the signs of acceleration and velocity when we are slowing down or the speed is decreasing? All right, awesome, different signs. Okay, so we're gonna do the same kind of thing. So I need to be above the axis, and so I'm gonna look at above with negative slope. Let's find that first. So it looks like above with negative is between 4 and 6. So let's write all that one out. So between 4 and 6, because the velocity is greater than 0 and the acceleration is less than 0. And again, on the review for it to auto grade, it had to be in that order. On the test, if you mixed up the order of where the velocity and acceleration are, I would probably hand grade that and go back and give you the points. Okay. All right. Decreasing, so it's also decreasing. So let's look at where it's also. So now I'm going to do, let me pick a different color, orange. We could be below with a positive slope. Okay, so below with positive slope, it looks like I've got two places where that's happening. So between 0 and 2 and 8 and 9. Let's see, is there enough space for that? Oh, here we go. 0 less than t less than 2 and 8 less than t less than 9. Because my velocity that time was negative and my acceleration was positive. All right, so that took care of item 2. We still got like 10 minutes left, right? Let's go to item 9. Okay, so item 9 is that one. And you'll notice it says calculator. I'll throw the graphing calculator in there if it's expected that you're using the calculator on it. If not, technically we're doing it by hand, okay? So for item 9, the position, for time t is greater than 1, the position of a particle moving along the x-axis given by p of t equals the square root of t minus 2. So we have, so which function do I have right now? Position, velocity, or acceleration? So where am I starting? Position, velocity, or acceleration? That's good. We are starting with the position function. Okay. Make sure I got into my item 9. All right. So if I'm starting with position, it says on what time interval is the instantaneous velocity equal to the average velocity of the particle? Okay, so I'm going to have to calculate some kind of time. When I see average and velocity, what kind of calculation am I doing? What does that mean I have to do? So here's the two options. I take the derivative or I use the slope formula. And we've already done this once, actually. So when I see the word average with velocity, do I want to take the derivative with the function or do I want to use the slope formula? Ah, good job, Jocelyn. This is, in fact, the slope formula. Okay, this is take the derivative. Okay, so I'm going to have to do both. All right. So I am going to rewrite p of t just a little bit. Is going to be t to the 1/2 minus 2. So over here on this part, I'm going to take the derivative, which is going to be 1/2. So I'll go p prime of t equals 1/2 t to the negative 1/2. That's it, right? And then I'm going to bring this back downstairs. I'm going to clean it up. So it'd be t to the 1/2, which would be 1/2 square root of t. So that's the derivative side. I don't have any numbers there that I can plug in. And I have to calculate time. But in average velocity, I have an interval, so I'm allowed to put the numbers in. So let's do that in a different color. We'll do that in pink. So what I'm going to do for the average velocity is I'm going to take the values that I have. These are my t values are my x values, so they get subtracted in the denominator. And then the numerator is subtract the y values, just like I would in a slope calculation. Oh, look at those nice square numbers. How nice was that? Because check this out. Square root of 16 is 4. 4 minus 2 is 2. Square root of 1 is 1. Minus 2 would be negative 1. And then 16 minus 1 is 15. You're leaving? You're going to grandma's. Are you done for the day already?
Yeah.
Okay, is grandma here to pick you up or is daddy taking you? Okay. Have fun.
Bye.
Bye. You got done early today.
Yeah.
All right. 3 out of 15. Must be nice to get to go to grandma's. You know what he's going to get to do at grandma's? Everything mom doesn't let him do. He actually has to go take down the Christmas tree at grandma's house. Grandma hasn't taken it down yet. He's got a job, but that's okay. He'll feed him like 12 hot dogs and 5,000 cookies. Okay, that's what grandmas are supposed to do, right? Okay, so now I got to finish this because I haven't found t yet, right? So we're going to take these two and set them equal to each other. So 1 over 2 square root of t equals 1/5. Let's see, cross multiply, so 5 equals 2 square root of t. Move the 2 over. I'm going to square both sides, so I get 25/4. Does that sound good? I think that should be the right answer in there, 25/4. All right, are we doing okay? I hope. I got a little bit of help on that one. I need more help on the next one. Huh? Okay, let's see if we can get through 12. And just because we've only gotten through 4 problems, it was really like 10 problems, right? Because there were like 6 or 4 parts, 4 or 5 parts in those, in a couple of those. Okay. All right, so 12. Let's look at 12. Looks like a short one, right? So a particle moves along the x-axis at time t so that its position is given by x of t equals 12 e to the negative t sine t. What is the first time at which the velocity of the particle is equal to 0? So how do I get from position to velocity? What calculus do I need to do? Ah, the derivative. Nice. Okay. And they were super kind to us on this derivative, weren't they? I can put this one on like the last test because, okay, are you taking the little guys with you? Okay. All right. So because what rule do I have going on here? Does anybody recognize the rule? There's actually a couple of them. What rules do we have to deal with on the derivative here? What are we seeing? Okay, Jocelyn says she sees a product rule. I see a product rule too. Okay, I like that. Anything else? Is there anything else we're seeing? There's another one hidden in there. Ah, if there's something else in there, it's got to be a chain, right? Look at that chain rule hiding up here. It's not a terrible chain rule, but it's there, right? It's embedded in our product rule, okay? So I 100% guarantee somewhere on the test, I'm not gonna tell you where, there is probably gonna be a product rule. Maybe not a chain in a product, but I will probably put some kind of product rule on the test. So make sure you understand the product rule because we wanna keep it fresh, okay? All right, so we are gonna start taking this derivative. I'm gonna go with blue, x prime of t equals, all right. So we got to take the derivative of the red. I'm going to do a little bit of work to the side because that's our chain rule one. So for lack of anything better, I'm going to call it that and do some side work on it. My orange is going to be negative t. So u prime is going to be -1. Y equals 12e to the u. What's the derivative of e to the u, guys? What's the derivative, everybody? And see, that didn't go away either. You have to know that, right? E to the u. And as much as you get to have open note, you don't have time to look all this stuff up. Okay, so you need to know some of these. And then times the derivative of the inside. And then I'm going to rewrite that out. So it'd be -12e to the negative t. So that's the derivative of the first part. And then we keep the green the way it is. All right, on product rule, what operation am I supposed to put in between? What operations do we put in between? Good, we haven't forgotten anything. Nice, good job, everybody, good job. Okay, so we're going to put a plus sign in between. Then I am going to keep the red the way it is, which was 12e to the negative t. All right, what's the derivative of sine? Tell me in the chat, what's the derivative of sine? All right, excellent, excellent, excellent. It is, in fact, cosine of t, okay? Now, I have to figure out, this is what's tricky about this one. It's not an easy problem, right? We got that part. And remember, on the test, if you did that much, I give you partial credit, right? You get probably we get 2/3 of the points for getting that far, okay? it says, what's the first time at which the velocity of the particle is equal to 0? This was velocity, right? I'm going to now set that equal to 0 and try to solve it. Okay, so I'm going to move, I don't know, I think I'm going to move this one to the other side because then it makes it positive. It really doesn't matter. So 12e to the negative t, cosine t stays on the right. I've got 12e to the negative t sine t. I am going to divide by the 12e to the negative t, because guess what? That makes it cancel. So what that means is, where is the cosine equal to the sine? So what is the first radian measure on the unit circle where the sine and the cosine are equal? Who knows that? Think about your unit circle. Where is the first time where your x coordinate and your y coordinate on the unit circle are the same? Where's the first time that that happens? Okay, so let's see. I'm going to start doing my unit circle, right? Hopefully you'll get a hint. So we're out 1, up 0. I'm going to change that count up. 1, 2, 3. Count down. 1, 2, 3. So what's my radian measure right here where I've got the same coordinates? What do we think? So we start with 0. We go to pi over 6. What's now? There we go. Now we've got it. Pi over 4. So our radian measure's got to be pi over 4 for the answer. That one was tricky, right? But if you got this piece, you got halfway, good job, okay? So again, I give you about 2/3 of the points for doing that part. This part, I give you the other third of the points. That was a nice question, okay? Because we took that thinking, like I kicked it up like 10 notches, right? Okay, we are technically at 41. So technically our synchronous time is over. And the BC kids get to review for a test too. So I'm going to have to let them in and review with them for a little bit. So I'm going to have that up through number 12. Okay. So here's the deal. I've done these before. I am obviously going to be videoing during third period. We will do as much as we can during synchronous time third period. I will probably give them like a 5-10 minute break, and then we'll roll into asynchronous time and I'll keep going. So if you are available during asynchronous third period time, you are welcome to come back. Okay, does that make sense? So you guys, and I will video it all. So you'll still get, and I will tell them that we're not going to do problems 16, 2, 9, and 12. Okay, so we'll get different stuff. Okay. What you guys need to do for the rest of the class period is take a break, right? We got to take a break. Not yet. Not till I'm done talking. Take a break. And then I did post in Google Classroom, okay, your, whatchamacallit, I did post a video of all the progress check problems because it could come from the review. I also am probably going to go into the progress check to make sure you did it, pick out a problem or two from there. So you might want to go through and look at those. And again, the concepts are all the same. I just give you a lot of different ways that I can throw the concepts to you on the test. All right. So that's why there's so many. Okay. Let's do a joke, right? And then we can go. Okay. Because I know that probably after listening to me for 45 minutes, you're probably done for a little bit. Okay. I know I'm probably done. I would be done. All right. Wait till college and you have to sit through an hour and a half. Did I lose Flipgrid again? What happened? Apparently I lost Flipgrid. Let me get back to it. Okay. Okay. There's a cameo by one of the other kids. So, and my husband Standy is sitting in the background, but here we go.
Okay, guys, me and Mikey are going to do a knock-knock joke while Daddy's working. Okay, so, knock-knock. Right there. Ouch. I just... Gesundheit, you have a very bad cold.
All right, that was a funny one. They were giggling the other day a lot with that one. All right, so you guys have, hopefully we'll see some of you later today. Be watching for videos, okay? And we will, I will get this one posted hopefully at lunchtime. and be ready to come in, take tests tomorrow, okay?